going to discuss cluster now. So cluster is a logical group of Websphere application servers work with together. So that means cluster having members. Members is nothing but application servers only. So we used to group servers as a cluster. So the advantage of cluster is first one is high availability. Second one is high availability or failover. Okay, and the second advantage is load balancing, load balance, and the third one is scalable. Okay, so here high availability, failover, and both are same. Suppose so the why we need cluster, so that is the question. So why we need means, suppose I have a server called server 1. This is Websphere application server. I have deployed one enterprise application ER file in the server. So that application name is some ATM application I have deployed in the server 1. Okay, so deployment is success and the server 1 is serving the request. Okay, so now here the question is, ATM application is very critical application. So we will have a lot of clients accessing the same application for 1 minute. Okay, so imagine how many clients can access the ATM application for 1 minute. We cannot count, right? So suppose the server can handle only limited requests. Suppose the server one able to handle 1000 requests, so it can handle only 1000 requests. So but ATM application contains lot of requests which are comes from the client for 1 minute. Suppose the ATM application getting 10,000 requests for 1 minute, but the server is can handle only 1000 requests. Remaining 9000 requests will be on failed state. So that will be the loss to business, that is business loss. So to overcome this problem, here we are grouping the application servers as a cluster. Suppose I have server 1 and server 2 and server 3. So I have created three servers, three web servers, and I have Websphere servers, and I have grouped as cluster. Okay, so this is my cluster 1. So I have deployed the same application in cluster level, same ATM application in the cluster level. So whenever you select cluster while deploying the application, that will be installed in server 1, server 2 and server 3. So that means automatically the ER file will be installed, deployed in the all the three servers, server 1, server 2, server 3. Okay, now if there any request comes from the client, suppose the server 1 is handling the request which comes from the client. So after 1000 requests, it is not able to handle the request. At the time the server may goes down, server may hang. So server will not respond to the client request. At that time business loss. So at the time the server goes down, server 2 take the responsibility to handle the request, because server 2 also having the same application. Okay, server 2 can handle over the, it can take the request and it can handle the request. Okay, suppose the server 2 also down, server 3 is there, server 3 take the responsibility to handle the request. So that is called failover or high availability. That means whenever one server is down while serving the request, another server take the responsibility to handle the request. That is called that is called high availability. Is it clear? Venkat, is it clear? High availability.
Yeah. But is it active active or active passive?
Sorry.
Is that high availability we can go for like active active or only passive mode?
Active
Active.
active. We have to put active active.
Okay.
Okay. And the next one is load balancing. Load balancing means load balance the load which are comes from the client. Okay, so that means suppose I have three servers in my cluster: server 1, server 2 and server 3. So whenever the client send a request to access something, which server will respond first? So all the three servers having same application, all the three servers are serving the same number of requests. So the here the thing is which server will respond first for the client request. So that is the question.
Active active all servers will respond, right?
All servers respond, but for one request, if three servers response means that is not good, right? Suppose you are drawing money, $1,000 from the ATM center. So if the three servers respond for the three requests, one request, you will get $3,000, not 1,000.
Three one server will automatically respond, right?
Automatically will not respond. It depends on load balancing algorithms. Okay,
Okay.
so in load balancing there is some algorithms. So using that algorithms the servers will respond. Okay, so we have three algorithm. First one is round robin, and the second one is weight based, random. So these three algorithms we have under cluster. Okay,
Okay.
suppose being an administrator we need to select this, we need to select the algorithm when we are creating the cluster. Okay, suppose if you choose round robin algorithm, the client request first hit server 1, second request server 2, third request server 3, again fourth request server 1, server 2, server 3. So like that is the server, the requester come and hit the particular server if you choose round robin algorithm. Okay, if you choose weight based algorithm, we have to give weights for the server. Weight is nothing but number of requests. So which number of requests it can handle. Suppose the server one can handle 10,000 requests. Okay, server 2 handle 900, server 3 handle 50. So I have make the changes like this: server 1000, server 2 900, server 3 like 5000. Okay, so imagine like that. Now if the client send a request, for that request server 1 will respond first because server 1 number is 10,000. So that weight is 10,000. Based on weight the servers will respond. And for the second request server 3 will respond, third request server 2, fourth request again server 1, again server 3, like that, weight based. Okay, and random algorithm means we cannot say which server will respond. It is taken care by cluster itself. Okay, so by using these three algorithms the servers will respond and it will provide load balancing through the algorithms. Okay, got it.
Yeah, but in weight based manually we will configure that weights or
We will configure the weights manually.
but how will decide like how many requests it will handle? What basis
Imagine like,
will decide?
yeah, we can give thousand requests for the server.
No, it
Okay,
depends on hardware.
it depends on hardware and application also, application critical.
Okay.
Okay.
Yeah.
And the third feature is scalable. Scalability means if I want to add one more server in the same cluster, I can add. That is server 4, I can add. Or if we want to remove the existing server, we can remove. So that is nothing but scalability. That means so we can add and remove the servers from the cluster without any disturbing the application services. Okay.
Yeah.
And here we have two types of clusters. First one is vertical cluster. And the second one is horizontal cluster. Okay. Vertical cluster means the cluster members are in single node and single physical server. Single node or multiple nodes. Okay. Vertical cluster means the cluster members, nothing but Websphere application servers, are in single node. Okay. Are in single node or multiple nodes. That means we can group the servers running in the different nodes. Okay, we can group what are the servers are running in different nodes. We can group as a cluster. Okay, so that should be in single physical server. That means one single CPU. The CPU contains multiple WebSphere application server nodes. Okay, so we can group that multiple nodes as a cluster. Okay, or single node having multiple servers we can group. So two chances: single node, multiple servers we can group, or multiple nodes we can group as a cluster. And these all are in single physical mission. So that is called vertical cluster. Horizontal cluster means the cluster members are in different missions, different missions and different nodes. Okay, that is horizontal clustering. So which one is the best, vertical or horizontal? Obviously horizontal cluster is best, because in virtual cluster we are conferring in the single physical mission. Suppose if the physical mission crash, if the the entire CPU crashed, the entire CPU is not responding, so the cluster members will also not respond. At that time we cannot access the application. If you use a horizontal cluster, the cluster members are located in different CPUs. If one CPU, the entire CPU goes down, another CPU contains application servers and application also deployed in the servers, then we can access the application. Okay, so that is the advantage of horizontal cluster. Okay, now we will see how to create cluster. Started EMGR first. It's taking time. So the MGR is started, and start the WebLogic web console also. From the Websphere administrative console, we can create the servers, and we can stop the servers also from the console itself. Login. Now go to the servers and server type. Okay, so check the servers, how many servers are available now. We have servers. um, I'm building server 2, server 3. Okay, we have three nodes. First node is app node 2, second node is custom node, third node is node 4. So all the three nodes having server 1, server 1 servers. Okay, and here come down in the servers list itself, there is a tab clusters. So click on cluster, go to the Websphere application server clusters. So here there is no clusters under this cluster tab. Now I am going to create one cluster. Click on new. Here specify the cluster name. So I am creating the cluster as cluster 1. Okay, and click on next. Okay, here if you observe, we have four options to add the application servers into the cluster. See here, select basics for the first cluster member. So that means for creating the cluster, we should have at least one application server created in the environment. Okay, here we have four options. Like first one is create the member using application server template. That means using application default template, it will create one server. Okay, so the second option, create the member using an existing application server template. So if you choose this one, here we have to select the node. So here we have to select which node, in which node the server we are going to add. So that means whenever we are creating the cluster, first member should be existing server. After that we can create the servers with our name, with own name. Okay, but the first time the server should be one, at least one server should be available in the environment. First we have to add that server. Okay, so here node 2, I am going to add the node 2. Okay, and the third option is create the member by converting the existing server application. Okay, so here also we have drop down list. Okay, and the fourth option is none, create an empty cluster. That means we are not adding any servers in the cluster as of now. So these four ways we can create a cluster. Okay, so here the good option is second one, because here creating a member using an existing application server template. Already one server is exist. Using that server template, I am going to create the members. Okay, select this one and click on next. So here give the member name. Member name is server 1 under this app, under this node. Okay, and click on next. Oh, sorry, one moment. Here choose the node 1, and server 1 is already there, and I am giving server 2 here. Okay, now server 2 added in this cluster. So I am going to add one more server, server 3, add member. Okay, now server 3 also added. Click on next and finish. save the configuration and check the cluster now. So cluster is created. Okay, so cluster is created, and now you can go and verify the servers here. Server 2, server 3 also created under app node 2. Okay, so these two are in cluster 1. So cluster name is cluster 1 and node name is this one, and we have created two members in the cluster. Or if you want to add server 1 into the cluster, we can add. Okay, so now go to the cluster and start the cluster now. Okay, so go to this cluster, and here we can see the cluster members. Okay, expand this cluster members. Already we have two cluster members. Okay, so click on details. Okay, here we have two servers and entire details we can see here. Okay, so now start these two servers under the cluster. Because node agent is not started, that's why it is showing we are unable to start. So first to start the node agent and then try to start the cluster. So I am going to start the node agent under app server. Profiles, app server 01. Start server, sorry, start node.bat, start node.sh. Once the node agent start, we can start the cluster from here. So we are here, remember one thing. So if we are starting the cluster means the cluster members also will start. No need to start server 2 and server 3 manually. So if you start the cluster, members also will start. Node agent is started. Now select the cluster and then start. Status is partially start because the node 2 is not synchronized with master configuration. It is showing the node app server 2 is not synchronized with the master configuration. This may prevent cluster 2 currently. So now do the synchronization from the console. Go to the system administration. Here is the nodes. Select the node and synchronize. So this is the node we have to synchronize, app server node 2. Click on synchronize. Synchronization done, and now go to the Websphere cluster. Here partially start. Now stop the cluster and start it again. It's taking time. System manager change.
Okay.
Sorry guys, the system hang. Hello Venkat.